I'd like to explain how to solve any titration problem and just the basics. There can be some nuances in every problem, but this will give you a really great overview. And I've already posted a handout like this on a class website, so you can follow along there as well. When you approach any titration problem and you want to solve it, first what I do is identify what type of titration problem it is. And there's 4 basic types: the strong acid, strong base, strong acid, weak acid, strong base, and weak base, strong acid. The first one is the one that is the analyte, the one that would be in your Erlenmeyer flask. And the second one listed is the one that you're titrating, the one that you're adding to it. Once you discover that, then you want to ask yourself, which one has the millimoles or moles in excess? So which one is there more of? You might have to do a little bit of math to figure this out, or convert from molarity to moles, but figure that out. Once you figure that out, you have a couple options here. In fact, in my mind, there's 4. If you have a strong acid or strong base in excess, that puts you in a region called the strong acid region or strong base region, respectively. And that problem is solved for pH trivially, and where you use equations like these, and you don't have to use an ice table. Now, if you find which one, the millimoles in excess, and you find it's the weak acid or the weak base, this is called the buffer region. In the buffer region, you don't need to use ice, but you're going to use an equation that's derived from the ice table, and that's called the Henderson-Hasselbalch, or I just put 2 H's here. And we'll use this in class. You'll see how to use it. Pretty simple. And then if you do the millimoles of excess, but you find, actually, no, I found out that the millimoles of acid equal the millimoles of base, so they're totally equal. In that scenario, then you have to know what kind of titration you're working with. If you're working with a titration and both are strong, then at the point where the millimoles of acid equals the millimoles of base, you're at what's called the equivalence point, or likely the end point. And in that case, for these kind of titrations, the pH is just going to be 7. It's totally neutralized. However, when they're equal at the equivalence point, if you have a weak acid, strong base, or weak base, strong acid, you can't just say it's 7. It's actually going to be just above or just below 7. So in that case, you actually do have to do an ice table, and you'll see us do an example of that. Similarly, if you have no titrant added yet, and you have a weak acid, strong base, or vice versa, you also need to use an ice table in that scenario. So notice the nice thing, most of the time in a titration problem you don't need an ice table if you want to avoid it, except when you have a weak acid, strong base, or the reverse at the equivalence point, or at the point that no titrant is added. Otherwise you're going to be in the buffer region or one of the strong regions.